Assalamualaikum. In today's episode, we solve a problem on angular kinematics, where a body is in rotational motion. What are the angular counterparts of the linear kinematics equations? Find out by joining me till the end of this video. Watch and learn. In rotational kinematics, we have three important quantities. First, we have the change in angular displacement, which we denote here as delta theta. Next is the angular speed, denoted as omega, and the third quantity is angular acceleration, denoted by alpha. Each of these angular quantities can be computed using different equations or formulas depending on what quantities are given in the problem. Angular displacement theta is related to the linear displacement d. That is, theta is equal to d over r. Right? Angular speed omega is related to linear speed v because omega is equal to v over r. And angular acceleration alpha is related to what we call the linear tangential acceleration, a sub tan, divided by the radius r. Notice that the radius of the circular path is the constant that connects or that relates the angular and the linear quantities. We also pay attention to the different units of measures used for the angular displacement, speed, and acceleration. So, angular displacement is commonly measured in revolutions, degrees, or radian. The conversion equivalents are given here. Angular speed or velocity may be expressed in revolutions per second or sometimes in terms of revolutions per minute, degrees per second, or radian per second. And angular acceleration may be measured in revolution per second squared, degrees per second squared, or radian per second squared. So we now come to our question or problem. A centrifuge in a medical laboratory rotates at a rotational speed of 3.6 raised to the third power revolutions per minute. When switched off, it rotates 50.0 times at a constant angular acceleration before coming to rest. Question letter A: determine the initial angular speed of the centrifuge. Question letter B: determine the angle in terms of radians through which the centrifuge rotates before coming to rest. Question letter C. Calculate the constant angular acceleration of the centrifuge. And question letter D. Calculate the time necessary for the centrifuge to come to rest. Moving on to our computations, we are given the initial angular speed of the centrifuge omega naught equals 3.60 raised to the third power revolutions per minute. The angular displacement theta is also given equal to 50 revolutions. And in part A, we are asked to find the angular or initial angular speed, but in terms of radian per second. So all we need to do is convert, all right, omega naught, which is expressed in revolutions per minute, into radians per second. That is 3.6 raised to the third power revolutions per minute multiplied by the equivalent of one revolution in radian. That is 2 pi radian is the equivalent of one revolution. Likewise, we also convert minute into seconds, right? So we multiply the whole thing by 1 minute per 60 seconds. So when we do our math, we get the answer omega naught equal to 377 radians per second. In part B, we are asked to determine the angular displacement theta through which the centrifuge rotates before coming to rest. Since we are given already the angular displacement but expressed in revolutions, so all we need to do is just convert it to radians. That is 50.0 revolutions is multiplied by 2 pi radian per revolution. That is, the angular displacement theta is equal to 314 radians. And in part C, we are asked to compute the angular acceleration alpha of the centrifuge, which is assumed to be constant. So our equation is alpha equals quantity omega squared. This is the final angular speed of the centrifuge minus the initial angular speed squared, or omega naught squared, and then divided by twice the angular displacement theta. So substituting our given quantities, we get alpha equals 0 minus the square of omega naught, which is 377 radian per second, and then divided by the product of 2 and 314 radians. So when you do our math, we get the constant acceleration alpha equal to negative 226 radian per second squared. The meaning of the negative sign is that the centrifuge is slowing down as it rotates until it comes to rest. And finally, in part D, our task is to compute the time denoted by small letter t. This is the time necessary for the centrifuge to come to rest. And the formula is simply the final angular speed omega minus the initial angular speed omega naught divided by the angular acceleration alpha. So substituting, we have the time t equals 0 minus 377 radian per second divided by the computed acceleration or angular acceleration negative 226 radian per second squared. That is, the time t is equal to 1.67 seconds. So we are done. Till the next episode. Mabuhay. Mashallah. Thank you very much for your indulgence. Please don't forget to subscribe to my YouTube channel. Alhamdulillah.